Okay, so now let's move on to Sutra 4. Again, let's pay attention to the pronunciation. So it is Paraavartya Yojayet. Yojayet. Okay, Paraavartya Yojayet. So again, you go by splitting it. Pa, Ra, right? VAR, where you pronounce stress, Tya. Then Yo, Ga, Yet. Yojayet. Okay, Paraavartya Yojayet. So this sutra is basically, direct translation of this fourth sutra is transpose and adjust. So the Vedic sages discovered that that division could be performed through a process of transposition and recurrence. Okay, rather than using long division, this approach establishes a pattern that can be followed to find the quotient directly. Okay. Um, this insight reveals the elegant efficiency of Vedic mathematical thinking. Okay. So this ancient Vedic sutra, provides an elegant method for division, like we just talked about it. So the traditional method uses a systematic, transposition technique that transforms complex divisions into simple multiplication and addition operations, right? So the essence of Parvata Yoga lies in organizing patterns, stress on the word patterns, where we can transpose the divisor into a more manageable form, right? So when we have divisors like 12, 13, 14, or 123 or 124, we transpose by writing the digits after the first digit with negative signs, below the divisor. So this creates a systematic calculation method that our ancient mathematicians perfected, right, thousands of years ago. So let's look at, the couple of examples. The first example we'll look at is, division by 12. So we'll take a number 1,225 divided by 12. So we'll write the divisor here, and the dividend is 1225 here, right? So like we said, we're going to take the first units digit of the divisor, right? And then we create a transpose of it. So that's the 2 becomes -2. Okay, and then we will set apart the last number, which is 5 in this case, for a reminder. The final, the last reminder we'll consider. Okay, and then that's step 2. And step 3, we're going to do the transpose method. So what you do is you take the first number here, or the farthest left number here, 1, you apply the transpose of -2. So 1 times -2 is 2, right? And then you take -2 and then you add the second number here. So -2, -2 plus 2. So that's 0. So you take 0 as carry over for the next transpose. So you bring 0 over here. Again, you multiply with the transpose, which is -2. So 0 times -2 is what? 0. And then you add the next number 2 here. So it's 2 plus 0 coming from here is 2. So this carryover is 2 now. So you take this 2 here, and then you again multiply that with the transpose -2. That's -4, right? And then you have this reminder which you set aside, 5. So you say 5 minus 4 is 1. Okay? So this one is the final reminder. So what happens, your quotient for the answer is 102. That's 102. And the final reminder, 1. Right? So that's the result. 1225 divided by 12 is 102, reminder 1. So saw how easy it becomes to take this kind of divisions by doing the transpose method, right? Transpose, adjust. So you take the transpose, and what's adjust? These are the adjustments you're making here. Okay. So let's look at another example, which is division by 14. Okay. Let's look at this. Again, we do the same thing. We put the divisor here is 14, and the dividend here is 1697, so 1697, right? So what's the transpose for? First step is transpose of -4. Okay. And then what you do, you start the adjustment process. So you did the transpose, as it says, and then you start the adjustments. So you start doing the adjustments. Before you do the final adjustment, you set aside this 7 as the last reminder. Okay. So like we said, step 2. And then you start the adjustment process. So what do? You take the first digit here, 1 times -4. 1 times -4 is -4. Then you add it to the second number, 6 here. So that 6 plus -4 is 2. You take the 2, apply the transpose. So 2 times -4 is -8. And then you take -8 and you add it to the next number, 9 here. And the remainder is 1. Continue on. You take that 1 here, reminder, apply the transpose. So 1 times -4 is -4. And then you left the 7 here. You did that. And the final reminder is what? 7 minus 4 is 3. So what is the answer? 1, 2, 1. 121, reminder 3. Right? 121, reminder 3. So result, 1697 divided by 14. And your quotient is 121. And the remainder is 3. Okay. So this method kind of demonstrates the profound mathematical insights, right, of our ancient Vedic mathematicians. So by recognizing that divisors slightly above power of 10 can be transposed into negative coefficients, they created a systematic approach that eliminates the need of complex long divisions. The beauty lies in its simplicity and the way it reveals the underlying mathematical relationship, right? So that's the beauty here. So today this principle appears in computer algorithms, digital signal processing, and advanced mathematical computations, including in algorithms used in LLMs, okay, large language models in AI. So understanding these traditional methods enhances our mathematical intuition and provides alternate approach to problem solving. So Paraavartya Yojayet teaches us that mathematical elegance comes from recognizing patterns. This word keeps coming up, patterns, and transforming complex operations into simple ones. So this ancient wisdom continues to inspire modern mathematician thinking and demonstrate the timeless nature of Vedic mathematical principles.